Hello, scholars. Today I would like to talk to you about variance. Variance is another measure of central tendency. What is our data doing? And homogeneity of variance is often an assumption for parametric tests when we have, approximately normal distribution and whatever to test our data for certain hypotheses. So homogeneity of variance means similar or equal variances across groups. So what is a variance? A variance is a measure of how the data points differ from the mean. Okay, how far apart are these data points from their mean? What's the spread? So variance means to find expected differences of deviation from the actual value. Okay, so variance depends on the standard deviation of a data set. Now remember, standard deviation are steps away from the mean where we expect such and such percentage to fall within one step away from the mean, plus or minus, I believe it was 68%, right? 2 steps, it was 97% plus or minus, and 3 steps was 99.7%. That's on a bell curve, right? So we can calculate the standard deviation. But the more the value of variance, the data is more scattered from the mean. If the variance is low, then it is less scattered from the mean. So let me show you what I'm talking about. Okay, Group A and Group B both have a mean average score of 80, both of them. But look at Group A. We've got scores ranging from 65 to 100. 80, 65, 100, 78, 77. Group B's scores range from 77 to 84. So the range of scores are much tighter for Group B. They're clustered closer to the mean than Group A. So likely we do not have homogeneity of variance. Now we can test for homogeneity of variance easily. Okay, now I can find homogeneity tests definitely under ANOVA. Let's see if we can get it in descriptives. Let's see. Variance. No. Okay, so we can test for homogeneity of variance under an ANOVA because homogeneity of variance is required for an ANOVA. Okay, it's an assumption for a parametric ANOVA. So let's see, I need a categorical variable. Education. My education people had, I believe there were 3 levels. So that's my fixed factors, my independent variable. And let's say I want to know if there's a difference for education on skill. My dependent variable, the numeric score, right? I can order a homogeneity test by going under assumption checks and hitting homogeneity, right? JASP uses Levine's test. There are more than one kind of homogeneity of variance test. There's Bartlett and there's a few others. Okay, so my homogeneity test finally popped up here. See it right here, test for equality of variances. The null hypothesis for a homogeneity test is that the variances are equal. Nothing going on, everything's equal here. So if I reject the null, if P, my alpha is of 0.05, if P is greater than if P is less than 0.05, I reject the null. If P is greater than 0.05, I fail to reject the null. My P is 0.420. that is greater than 0.05, I fail to reject the null that the variances are equal. So my assumption of homogeneity of variance is met. P equals 0.420. Okay, let's cover one other thing while we're talking about homogeneity of variance, but it's nothing that you're going to need to worry about as a novice researcher. We can add corrections to some of our statistical tests, Bonferroni and, other types of corrections. Sometimes if we're testing more than one variable or a variable more than once, it can artificially inflate the power of the test. And if it does that, the chances of a type 1 error, a false positive, dramatically increases. So when we're testing a variable more than once in our tests or in our research, sometimes we use corrections. Okay, I just thought I'd mention that. You don't need to use that, but we can use corrections in some of these tests. See down here? Corrections. Bonferroni correction is oftentimes the one I use. But there are corrections that you can order when you think that your test might be too powerful and might artificially inflate it. It artificially inflates the possibility of a mistake. So that's what corrections are used for. You're not going to need them with a simple one-way ANOVA. Okay? Thank you very much for your time.